In this video, we're going to take a look at one of the web challenges from the Akasec CTF 2024. The challenge is called Upload, and the description says, navigate a mysterious file upload journey. So we do have the source code to download, and we'll take a look at it very soon, but let's just open up the two links first. One of them is called Chal, and it's got a login, a sign up, and a home button. And as you can see from the image here, Akasec and I guess the challenge creators are doing what they can to shine a light on what's happening in Palestine. So respect for that. The second is an admin bot page where you can enter a note URL. So this immediately made me think of a cross-site scripting attack. Maybe we need to inject some XSS into this site and then provide the link here, which will steal the admin's cookie. That's a pretty standard flow for this sort of challenge. But that's it. I just wanted to have a quick look and see what we had here. I'm not even going to go and sign up for an account. I'm just going to go and take a look at the source code. So I moved over to VS Code and I've gone straight to the bot.js file because it's likely to have less code in it and potentially will have the flag if it's been inserted into a cookie and we need to steal the cookie. However, it doesn't actually. All it does really is the bot will visit a URL that we provide and then it will close the browser. So there is no cookie with the flag for us to steal. Let's go over to the app.js and see what's going on there. So in app.js, if we scroll right down towards the bottom, we have the flag endpoint. So we want to try and work out what the goal is, and it looks like the goal is to call this. Let's just try and go to the site again and just put that in. You see it says access denied, and the reason being is it has this IP check here, 127.0.0.1. So maybe we need to try and find a bypass for this to make it look like we're coming from 127.0.0.1. But if that was the case, what would be the point in the bot? Because if we're able to just access the flag page by spoofing our IP address or something, changing one of the headers, then we wouldn't actually need to send anything to the bot. So it's more likely that we want to send this flag endpoint URL to the bot, and then it's going to open it up, and because it's calling it from the local host, it will receive the flag. The problem is, how do we get that flag back to us? Well, if we scroll back up, let's see what other functionality the site has. I'm seeing some mention of uploads here and pdf.js. Here's an upload endpoint, which is going to take a file, and then it's going to upload it, and it's going to return the location of the file. If we continue a little further, we'll also see that there is some validation. So it's checking the MIME type to make sure that it equals application/PDF. At first, I thought maybe we could just upload some other kind of files. So maybe we can upload a HTML file that has some JavaScript in it. And then we just change the MIME type to equal application/PDF, but it'll still have the HTML extension. It'll render, then we can just send that link over to the admin. However, that didn't work. I was able to spoof the MIME type and upload the file, but whenever you try to access it in the browser, it's just going to throw up a lot of errors because it's trying to render the file as a PDF. Let me just quickly show what I mean anyway. So I'll create a file called exploit.html, and I'll just put in here a very simple script which should pop an alert. And if we go and create a new account, there we go, we can upload a file. So I'm going to select the, where is it? Desktop, upload, exploit.html, upload, and there we get an error saying only PDF format is allowed. So I'm going to go back to Burp Suite, I'm going to send the request to the repeater, and we know that the only validation being done, it wasn't on the file name, so we can leave .html in there. We just need to change this to application/PDF. We do that, and now we get a successful message. We can go and try to view it, and we don't see anything. If I open up the console, you'll see here that we've got this error saying missing PDF, and then we've basically got a stack trace here because it's trying to render as a PDF, as you would probably expect, and it's not able to because we gave it some HTML. So the next thing for me was to go and try and find out if there are some vulnerabilities with this PDF library. Just had a look up here and saw that we've got pdf-js-dist. So I'll take a copy of that. Let's go to Google and just search for pdf-js-dist exploit. And I did that, and I think, what's this? 1, 2, 3, 4. The fourth result is from the 20th of May, so about 6 weeks ago. That makes it a pretty good candidate in my opinion. I'd encourage you to read this article, but let me just try and summarize some of the key points. The vulnerability is in pdf.js. It was found by Codian Labs, and it allows attackers to execute arbitrary JavaScript code as soon as a malicious PDF file is opened. It affects all Firefox users before version 1.26, and also many web and Electron-based applications. It also tells us here that it's packaged with pdf-js-dist, which is what we're using in this challenge, and that has 2.7 million weekly downloads. It mentions that the PDF format is famously complex and there are often vulnerabilities found. However, most of them are written in C or C++ as opposed to JavaScript, which means that there are no opportunities in this case for memory corruption problems, but it comes with its own set of risks. In this case, the vulnerability arises due to an oversight in a specific part of the font rendering code. So fonts in PDFs can come in several different formats, some of them are more obscure than others. For modern formats like TrueType, pdf.js defers mostly to the browser's own font renderer. In other cases, it has to manually turn a glyph or character description into curves on the page. To optimize this for performance, a path generator function is pre-compiled for every glyph. If supported, this is done by making a JavaScript function object with a body containing the instructions that make up the path. So here's the code, as it says here. If we can control the commands that are going into the function body, then we could potentially inject our own code. So they dig into how those commands are generated, and they find some of these commands in the code to save, transform, scale, and restore. They go on to modify the pdf.js code to log the generated function objects and find that it indeed contains those commands. And they want to try and work out which of these might be interesting. They don't see any use in the likes of quadratic curve 2 and Bezier curve 2, but there is a transform command above which uses the font matrix .slice, and the array is copied with .slice inserted into the body of the function object joined by commas. The code assumes that it's going to be a numeric array, but is that always the case? Any string inside the array would be inserted literally without any quotes surrounding it. Hence, that would break the JavaScript syntax at best and give arbitrary code execution at worst. So how can we control the contents that go into the font matrix? Well, there's a default value, which is given here, but it can often be set by the font itself, i.e. within the embedded metadata. How it's done depends on the font format. However, the authors mention that this isn't particularly interesting for us, since even if we could inject a string or some code in there, no sane PDF reader supports this fully, and most will just try to read a predefined key value pairs with expected types. In other words, it will simply look for an array of numbers, and if we try to pass in an array that has strings or something else in it, it just will fail to parse it and it'll be rejected. However, it turns out there's one more potential origin for the matrix. It's also possible to specify a custom font matrix value outside of a font, namely in the metadata object in the PDF, so the metadata of the PDF rather than the font itself. And looking carefully at the partial evaluator.translateFont method, you can see that it loads various attributes from PDF dictionaries associated with the font, one of them being the font matrix. So, looking at the PDF format, they essentially go and add in the font matrix here. It has a numeric array, as would be expected. Whenever they modify that to include this foobar, and then check the output, it's actually inserted into the function body. Now, in order to get from a string to some arbitrary JavaScript code, we need to modify the syntax. So here's an example of an alert where they have first closed the c.transform function, and they're making use of the trailing parentheses. And as you can see, they render the PDF and it pops the alert. And they provided a proof of concept PDF file that we can download here as well. Let me just save this and let's go back to the upload page. We'll upload the POC and we don't get an alert. We instead get something saying missing PDF, and let me try that again. Upload, no, okay. I probably should have done this in a local Docker instance because I think there's some issues with the server. I think that's why they've changed it from the original IP that I solved it on to this DigitalOcean. Let me try it again. There we go. All right, so it pops the alert, and if we go and have a look in Burp Suite, we can view that request. Here it is. Let me send it to the repeater, and this has our PDF in it. We can just go and search here, font matrix, And here's the payload. So you can see we've got our numerical array, but in there we have closed off that function, injected our alert, and then closed that off as well. So we could go and basically start modifying this, but what we'd normally do here is have some kind of command that will steal like the cookie, return it to our local server. In this case, it's not in the cookie. We need to do the server-side request forgery. So we need to forge a request, which the admin is going to go and make a request on the local server to that flag endpoint. And then we need to recover the response, or exfiltrate the response, should I say. So how did I come up with the payload that we need here? Well, I basically went and asked ChatGPT to tell me how to fetch the contents of another page and then send them to another web server. That's literally exactly what I typed. And this is what it gave me. So let me just open up a new file so that you can see it. In fact, it didn't give me this. It gave me something that was about 50 lines of code, and then I just said shorter 3 or 4 times until eventually we landed on this. So we can put in our attacker site here. You can use something like ngrok or request bin or something like that. I have a custom server that I'm going to use. Let me just go into this challenge directory. I'm going to create a local Python server. So this is just on the local host. And then I'm going to expose that to the internet. I'm using a custom service here, which is just going to mean that I can use the same domain each time. And it basically means that if you try and go to this site, cat.tunnel2.dev, it's going to go to that uploads directory. You can see the requests here in both of these, and this is what we're going to try and use to exfiltrate the data. So I'm going to go back to the script, and I'm going to replace the attacker site with, oh, that's not right. Where is it? I'm going to replace the attacker site with this. And okay, let me just undo that. Get rid of this HTTPS. Okay, so that's done. Now, the next problem I had was with escaping characters. I wasn't really sure exactly which characters I needed to escape here. And I played around with it for a little while. I just kept getting errors with whatever I was putting in. In fact, let me just throw something in here. So let's try and do that. And there's just too many brackets and stuff to escape here. I think we also need to escape these backticks as well. So what did I do? Well, I just went and Googled again for a proof of concept. So just search like CVE-2024-4367 proof of concept. And I came across this GitHub repo, which basically has a script in it where we can just provide the command that we want to insert, and it will generate that PDF for us. So let's do that. Let us copy this file, and I'm going to just create a new file called exploit.py. We'll paste that in there, and then we're going to do like Python exploit.py, and then we need to provide our scripts. Let me get rid of the spaces here. That's not going to help things. Oh, so what's this doing anyway? I didn't even talk through that. So yeah, it's going to make a request to the flag endpoint, and then it's going to grab the response.txt whenever it receives a response, and then it's going to fetch our attacker server. Oh, I need to take this backslash out, forward slash. It's going to make a request to, oh my god, to our server, and in that it's going to include the response that it retrieved. So yeah, let's give it a go. I'm going to just put that in here, and we get unexpected token. That's because we need to put some quotes around this. So let me do a double quote here. Oh, but this is a double quote as well. Right, okay, let me do, how does that look? Okay, bad substitution. So it does generate a PDF, but if we try to upload it, it won't work. And the reason being that it had some issues, I think with the $sign and with the backtick. So if we do it again, this time we're just going to escape that. So escape. Oh, I need to escape the backtick as well. And also this one. There we go. I don't see any errors this time. So let's go and upload the file. All right, got to log in again. Upload, and then it is in here. poc.pdf, upload. All right, look at this. It has just flooded the console with errors because it's trying to make this request to the flag endpoint, and it's coming back with a 403 forbidden. Because we're not on the local host, we need to forge that request on the server side. But if we go and have a look at our logs now, notice that they are filled with this error, access denied. Well, we're only getting that because we're trying to access the flag endpoint from a non-local IP, but the admin bot's not going to have that problem. So let's just take a copy of this URL here and let's send it to the admin. It comes up and says it doesn't match the format. This basically just needs to be localhost. So let's do HTTP 127.0.0.1 5000. All right, and it's going to try and visit the note. Let's go back to our logs and look at this. We now have this encoded URL encoded string. So we can just go and literally URL decode, paste it in, and there's our flag. All right, hopefully that made sense and this video wasn't too hard to follow. I've been off for a couple of months, so just need to get back into the flow of things. Just to summarize then, we exploited a cross-site scripting vulnerability and an SSRF vulnerability. So we were able to use that vulnerability in the pdf.js library, which was the font rendering exploit. And we used our XSS exploit to forge a request to the flag endpoint. And since we send that to the admin, it's coming from the server side, i.e. the local host, so server side request forgery. And that means that the validation of the 127.0.0.1 address will pass. And then the XSS payload will subsequently issue a request to our server with the response of that first request included in the get parameter. Anyway, I'm going to put a write-up for this on Gitbook as well, so if this wasn't clear or you just want to have a read through that, then the link will be in the description. And that's it. I hope you've enjoyed this video. If you have any questions or comments, leave them down below. Thanks.